All right, so we're going to be talking about section 6.2, slopes of parallel and perpendicular lines. But before we do that, I'm just going to go back and finish answering this question right here, which I didn't get it on the last video. So just go back one page here. The slope of a playground slide is 1.6. Okay, so that's your slope, M, right? If the ladder is 7 feet tall, right, how far horizontally will the slide travel? There just should be a slide here. I see that now. Right, if the slide is 7 feet tall, how far horizontally will it travel? Well, if this is the slide, so let's say you go up here, right, this is the ladder, and then goes, I guess if the ladder, sorry, that's what I meant, it is correct. The ladder is 7 feet tall, so if this part is 7 feet, okay, this is your slide. They want to know how far horizontally will you travel, right? And if you think about it, this is the distance in x, right? And this is your change in y. But in this particular case, you don't want to be using the y2 and minus y1, like this formula. You don't want to be using that. You just want to go, the slope is rise over run. That's more convenient in this case. The slope is 1.6, right? The rise in this case, this would be the rise, and this is the run, okay? The rise in this case is 7 feet, and the run is x, right? So you don't know what it is. You want to find out. Here, allow me to introduce the cross multiplying and dividing. So we'll put a 1 down here, and my homework is going to get in the way, but you cross multiply this way and this way. So 1.6 times x, we'll continue over here, 1.6x, right? 1 times 7 is just 7. So now you went from a proportion to just an equation here, a one-liner, and then we divide both sides by 1.6, right? And you can use your calculator for that one, which is 4.375. So we'll round to 2 decimals, and we have units here, and that'd be feet. So this is a word problem. You should add units. And keep in mind when it's right now, I know technically the slope would have been negative, but when it's a word problem, right, like when it's a roof like this, we would talk about this slope the same as this slope. Like the pitch would be the same. So in a word problem, we don't worry about positive or negative, but just follow the kind of like the sense of the context. Like they're not really giving you any negatives there, so you don't have to worry about it. When you're finding the rate of change or slope using the formula, right, then yes, make sure that if the answer is negative, that you stick with the negative, okay, and units. All right, 6.2. We're going to talk about slopes of parallel and perpendicular lines, okay? So parallel lines are two or more lines that never meet. They never cross, they never touch. Okay, sorry about the highlighting, it kind of bled through the other page there. So parallel lines are two or more lines that never meet. That's a definition. A line with a slope of 1, I think we can just make up numbers here. A line with a slope of, let's say, 2, right, positive, let's be specific, is going to be parallel to a different line with a slope of +2. This is just an example, right? If you notice that lines have the same slope, they're going to be parallel. Okay. Perpendicular lines have slopes that are negative reciprocals. Okay. They're negative reciprocals. What does that mean? Right? So I'm going to give you an example. A line with a slope of, let's say, plus 2. Let's stick with the 2. If you have a line with a slope of plus 2, this line with a slope of positive 2 is going to be perpendicular to a line with a slope of negative. So it would have to be negative. So opposite sign of what you started with. And reciprocal means you flip. Like you do this. That's what reciprocal means. So the numerator goes into the denominator, and whatever the denominator used to be here, which is 1, will go up top, right? So this would be, these two would be considered negative reciprocals of each other. So how can you check? Well, if you go negative 1/2 and you multiply it by 2, right? This cancels out, and you would get a negative 1. Okay. If you multiply the slopes and you get a negative 1, you know it's going to be perpendicular lines. And the notation for perpendicular is this symbol, and the symbol for parallel is this. So if lines are parallel, we use that symbol. If lines are perpendicular, we use this over here. So let's use this line here on this side as an example. If you picked a point, and this would be a point right here, right? If you pick that point because it's right on an intersection, you actually rise 2 and go over 1 to get to the next point. And it's 2, 1 to get to the next point. 2, 1. So this has a slope. The slope for this line is 2, this particular line. And it's positive 2 because it's increasing from left to right. You could have found that 2 by picking any 2 points, writing down the coordinates using the formula. You could have done that as well. This is just the counting method right on the line. Okay. What about a line with a slope of negative 1 over 2? What would that be? Well, let's start anywhere really on this graph. If you started, I'm going to use a blue pen here. If you started somewhere over here, okay, so I'm starting at negative 2, 2. It wouldn't matter where you started, but let's use the slope of negative 1 over 2, the negative reciprocal. This means that you're dropping 1 and you're running 2. You're dropping 1 and you're running 2. You're dropping 1 and you're running 2. So I made a bunch of points there. Now I'm going to actually sketch that, connect the dots there. This line has a slope of negative 1/2. So we're just concerned with the slopes now. These two lines, when you notice that they have a negative, they're negative reciprocal of each other. So let's say you started actually with a slope of negative 1/2, right, for this line. If these lines were already drawn, right, you would have figured out, oh, okay, this line has a negative slope for sure, and it's actually negative 1 over 2. And then you go ahead and find the slope of this line, which is really, if you think about it, it's 2 over 1, right? It's 2, 1, 2, 1. You should see that they're negative reciprocal of each other, because you could make a negative reciprocal of this, which means that you would have to apply a negative to this, which would turn it positive, right? and you would have to flip it, which makes it 2. So let's practice a few here. Example of negative reciprocals. Okay, if you have, for example, a slope of 3/2, what would be its negative reciprocal? It would be a slope that would be perpendicular to this, would be, you have to change the sign of it, and it'll be flipped. So these two are perpendicular, and they're negative reciprocals of each other. If you had a slope of -5, let's say, and they asked you, hey, what's a slope that would result in a line that's perpendicular to a line with a slope of -5? Well, you'd say, hey, a slope that is perpendicular to that would have to be a negative reciprocal of what you started with. So in this case, when it's a whole number and not a fraction, maybe put that 1 over there. It helps you. You have to flip it, so that would be 1/5 now. And it used to be negative, now it's going to be positive, right? Because you're putting a negative in front of whatever was already there, and you're flipping it. So that results right now in a positive 1/5, right? And this just continues on. Like, you should recognize, okay, to go from here to here, what happened? I flipped it. And when I multiply this, watch this. If I multiply these two, you end up with a -1. If you multiply these two, you also end up with a -1, because the 2's cancel, the 3's cancel. So you end up just with a -1. So that's the fail-proof way of finding out whether or not lines are perpendicular. So knowing that, we're gonna actually now look into figuring out if line segments or lines are parallel or perpendicular. Okay, so, and we just apply this test by observation of their slopes, we will determine that. So let's see here. Line EF passes through these 2 points. So it's a line that passes through these 2 points, which is good. Line CD passes through these 2 points. Line AB passes through these 2 points. So you've got 3 different lines. Are these parallel, perpendicular, or neither? Okay, so let's we're going to do EF here. So I'm going to do it 3 columns like this. Okay, EF, we're going to call the first pair x1, y1. The second pair, we're going to go x2, y2. So you have no graph whatsoever. It's simply by just by looking at the points. So then you got to use, right, slope of EF, that's another way of writing it, would be y2 minus y1 over x2 minus x1. So slope of EF, okay, would be 6 minus -2, watch the double negatives, and that would be -1 minus -3, making sure I don't mix up my numbers, and this will result in a positive. This would result in a positive. 6 plus 2, -1 plus 3, and that would give you 8 over 2, which is 4, right? So the slope of line EF is +4. We're done that. Now we're going to do slope of CD, or I guess I could have written down slope of EF, slope of CD. Okay, there it is. And I'm going to skip the formula. I'm just going to go y2 minus y1, and then it's x2 minus x1. And that would be 7 plus 3 really, and 1 plus 2. And that'd be 10 over 3. So right now you're looking at these two. Well, they're not the same, and they're not negative reciprocals of each other. So these two are neither. Okay. just by observation. Slope of AB here would be y2 minus y1, x2 minus x1. And you're going to get negative 8. And here you get negative 2 plus 4, which is negative 8 over 2. And that would give you negative 4. There we have it. And, oh wait, this is supposed to, I found a mistake here. If this is negative 1, so this is 1 minus negative 1, so that should be just plus 1, my bad, and that's over 2, so that gives you a 5. You can see that there are no negative reciprocals. A negative reciprocal of this would have been negative 1 over 4. So, and no equal slopes, no negative reciprocals. Therefore, neither. These lines are just going about their way, but it's not none of them are specifically parallel or perpendicular. Okay, which is what we're looking for. ST passes through these 2 points. UV passes through, are they parallel, perpendicular, or neither? So slope of ST would be negative 5, right? Y2 minus Y1, x2 minus negative 2. So you get negative 12 up top. This gives you 2, right? Plus 2, which is 4. And that gives you negative 3. So slope of ST is negative 3. And we're going to do slope of UV. That'd be y2 minus y1, x2 minus, look, notice a lot of double negatives, right? So this gives you 3 over, this would be positive. So this is 7 plus 2, which is 9. That you need to reduce, okay? The 3 goes in here once, the 3 goes in there 3 times. So it's 1/3. So here you should be able to see something happening. These are negative reciprocals. So MST is perpendicular to the slope of UV. Since the slopes are negative reciprocals. Check, right? Slope of ST times slope of UV. That's negative 3 times 1/3. 3 goes in there once, goes in there once. So you end up with negative 1. They are perpendicular. That's how you check. For sure, if you're not sure, that's how you check. Okay, so they're not parallel, but they're perpendicular. Okay, perpendicular. We need to know that term because they're negative reciprocals of each other. Okay, so we can apply this to, for example, we'll see this could have been 3 lines that form a triangle. And you would have to check all the intersections to see which 2 lines perhaps are negative reciprocals of each other. And then you can conclude that it's a right triangle, or you can conclude whether a quadrilateral, which is a 4-sided shape, is a, if it's a rectangle or a square, because you need 90-degree angles, right? 3, determine the slope of a line that is perpendicular to the line GH. All right, so what we need to do is find slope of GH. Okay, that's the first thing we need to know. So slope of GH, and again, x1, y1. I would recommend you label it every time so you don't mix it up. And then so it's -2 minus, make sure you write that down every time, and then you go get the other one. And then it's x2 minus -2. Lots of double negatives here to prove the point. So this is -5 over 1 plus 2, that's 3. A slope that would be perpendicular to this one would be the negative reciprocal. So make that positive, right? I will put that there just to make clear you understand, and you flip it. So whatever you start with, you flip it, right? That comes there, this comes there, and you change the sign. What if you started with a negative, it goes positive. If this had been a positive, you would have had to flip negative. Check. We're going to go -5/3 times 3/5. These two cancel, right, to a 1. These two cancel to a 1. That's -1. So you found a slope that's perpendicular to GH. Okay. And we can do a little check here. That's, I guess, why I put this diagram here. So if you have -5/3, so let's start anywhere. Let's start up top here. If you go 1, 2, 3, 4, 5, because you're dropping over 3, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3. That's our this line here. And then we go with this one. Let's start over here. Let's make our first point. So we go 1, 2, 3 up, and then 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. So if you graph these, they should look perpendicular. They should look like they meet at a 90, right? Right there. So it wouldn't matter where you started, they would meet at a 90. Okay. Let's do one more here. Determine the coordinates of J so that the line GJ is perpendicular to the line GH. And I did not leave nearly enough room. Okay, so we're gonna do this here. B is gonna be done over here. Okay, 3B. Let's dedicate. So knowing that G, right, is -2, 3. We're still talking about G up there. And you want coordinates of the coordinates of GH is already given. So we know that GH is 1, -2. You want G, which is -2, 3, J, right? So that it's perpendicular. So both of them are unknown to us. And I think this one I'm just going to do it the short way. You know what? We're going to put this on hold. I'm running out of time. Class is about to start. So just put this on hold. We'll reconvene. But the homework that you can do for now, I'm going to give you the homework. There's the homework for this section. If you have any, we're going to figure this out if this is a rectangle. We're going to complete the notes later as well as for this part right here. I'm going to do that on Monday, Tuesday, because Monday is an in-service. Okay. Take care, guys.